Hey everyone, welcome back to Amazon EKS series. In today's video, we are going to talk about a very important production topic, scaling. In real world Kubernetes workload, traffic is never constant. Sometimes it's slow or sometimes it spikes. And that's exactly why scaling becomes critical in production environment to handle load balancing efficiently and also to optimize cost. And now when it comes to the node scaling in EKS, we mainly have two options, Cluster Autoscaler and Carpenter. Both of them solves the same problem, but they work very differently, and each has its own feature, benefits, and use cases. Choosing the right one depends on your workload and architecture. And in this session, we are diving deep into the cluster autoscaler. Agenda of this video. So we'll start from understanding what is cluster autoscaler and how it works. Then we'll look into the basic stuff of how a pod creation flow in Kubernetes looks like. And then we'll look into the scheduler controller behavior, node groups, autoscaling group in EKS. And then finally, we'll perform an end-to-end hands-on demo on this cluster autoscaler. All the codes, documentation, readmes will be present in this GitHub repository. Link will be provided in the description. So do follow this. So in this cluster autoscaler, you can follow all those, and Carpenter, which will be coming in the next session, will be present in this. So all the codes will be present here. And today we are doing complete end-to-end demo using Terraform. All VPC setup, creating EKS, private EKS cluster, roles, policies, everything will be done using this Terraform. In just one click, complete infrastructure will be set up, and I've already taught you how to create this EKS, VPC, VPN both via console and Terraform way in my previous videos. So I highly recommend you to follow this playlist where you can get complete end-to-end knowledge about this EKS. And now without getting late, let's get started. So mainly we have two different types of node scalers, cluster autoscaler and Carpenter. Both does the same work, but both work differently. So what I will do is I'll explain you what is cluster autoscaler in a brief way, and we will dive deep into this in slightly. So I'll explain with this diagram. So what we have is we have a control plane and we have a worker nodes. So in control plane we have our etcd API servers schedulers running, and in worker nodes our workloads are running, right? So when I say worker nodes, they are not just a worker nodes, a EC2 instance. Basically they are wrapped inside this node group, and inside this node groups your EC2 instance are present, and in this EC2 instance your actual pods are running like this. Pods are running, and inside these pods your application is running, containers and all those things, right? And this node group can have any number of pods, any number of EC2 instance depending on this min, max and desired size, right? So when the number of pod increases, this EC2 instance will not be able to hold all these EC2 instance, all these pods, and some pods goes into the pending or unschedulable state. And in such scenarios, what we want is a new EC2 instance to come in on which we can host this pod, right? That's where the cluster autoscaler does. Cluster autoscaler launches the new EC2 instance in this node group, and in that EC2 instance, these pods can be scheduled. So, in nutshell, what cluster autoscaler is? Cluster autoscaler is a Kubernetes component that automatically adds or removes the worker nodes in a cluster based on pod scheduling needs. That's what the cluster autoscaler is. Now we will dive deep into this, how that pod schedules, how that pod is in scheduling state, and all those things. So now let's dive deep into this. So let's look into the first, how a pod deployment flow looks like. So when a user applies kubectl apply, this deployment creates a replica set, and that replica set eventually creates a pod. But pod does not directly come into the running state. Initially, it's in pending state. Then this scheduler is responsible to launch this pod in one of the node which is best suitable for it. And then each pod will have its own metrics like CPU, memory, or any other metrics that we are tracking. And then this pod is exposed using this service for the traffic. Right? This is how the normal deployment looks like. So when the traffic increases, average CPU utilization crosses the threshold. Now, what average CPU utilization means? Let's say you have 10 pods running inside that node, and then all the sum of CPU utilization of all the pods divided by 10. So you will get the average CPU utilization of that 10 pods. If that average CPU utilization crosses the threshold that you have mentioned in your configurations, if that crosses, then what happens is, so here the average utilization has been crossed, and here HPA is triggered. HPA is triggered means horizontal pod autoscaler. So horizontal pod autoscaler, it does is it updates the replicas inside this deployment, and if the replicas is changed, number of pod increases and pods initially comes in pending state. And again, scheduler is responsible to look for the best suitable nodes to launch those pods, and eventually the pods comes in running state. And also average CPU utilization again goes down. This is how the normal flow looks like. And again, if the traffic increases, this node does not have that too much capacity to launch too many nodes. And eventually, what happens is pod stays in pending and unschedulable status. Pod status is pending and unschedulable. And that's what the cluster autoscaler is looking for. And whenever, if such pods are found which is in pending and unschedulable state, autoscaler is triggered. So let's look into that now. So cluster autoscaler is triggered. It is looking for pending and unschedulable pods. And if it is found, a new node is launched. And here node and EC2 instance means the same. So new node is launched, and again that new node is launched not just directly. There's a set of way to follow. As I've told, all the nodes EC2 instance are present in that node group, and each node group is associated with one of the autoscaling group. As you, if you have seen that carefully in your console, in the node group compute section, if you will go inside that node group, you will see that one of the autoscaling group is associated with that node group. So this autoscaling group is responsible to launch new nodes in this node group. So how the flow looks like finally? So the pod is in pending state, cluster autoscaler is triggered. Cluster autoscaler, once it is triggered, ASJ, which is autoscaling group of that node group, it calls the new EC2 instance in that node group. It runs that new EC2 instance in that node group, and eventually the pods which are in pending and unschedulable state comes into the running state. And again, you may have this doubt: if this autoscaling is launching the nodes in this node group, which type of, which instance type of EC2 instance, which EC2 instance type this autoscaling group is launching? Means in AWS we have n numbers of instance type, which type of EC2 instance it is launching, and all those depends on your configurations only. So let's get into this documentation. So in this, come to this EKS.tf. Here I have mentioned that, see here, resource AWS EKS node group. Here we have mentioned that instance type as where.instance type. So what's the value of that is T3 medium. So only the instance type of T3 medium will be launched in this node group. All the EC2 instance which will be present in this are of type T3 medium. And again, you can pass any different EC2 instance as you want: T3 medium, T3 large, or any EC2 instance. And again, the question remains same here also. If we pass multiple EC2 instance here, then which instance autoscaling group will launch? Which EC2 instance it will choose? So what it does is, based on the pods which are in unschedulable state, It chooses the best EC2 instance that matches that pods to run, and then launches that nodes. Going from lower to bigger means it will first look for T3 medium. Will it best fits for our all the pods which are in unschedulable state? If not, it will go for slight bigger EC2 instance than that. That way, it launches the new EC2 instance in this node group. So now let's perform the hands-on demo over here. So this is complete Terraform code. So what I will do is I will walk you through this code, but I will not explain you in depth because I've already explained these all codes in my previous videos. I'll go with this code a bit fast way. So firstly, let's go for VPC setup. So the local variable, so we can use this cluster name throughout this file. So resource VPC. So here we are creating VPC. Also we are adding some tags. So CIDR block and host name and support and all. Internet gateway, subnet, public subnet, private subnet. Here we are creating private subnet, and then route tables for public route table attaching with the internet gateway, and then association of that route table with our public subnets. And then we are creating NAT gateway also. Here we created elastic IP, and here we are creating NAT gateway, and here we are creating a private route table, and here we are associating that private route table with our private subnets, and then here we are creating uh, what is this security group for our cluster. Here, this is the security group for our cluster. We are opening 443, and this is egress, and also adding some tags. And again, you can see some tags as a carpenter.sh. You can ignore this tag for just this video because these tags will be used in our next video. Only carpenter.sh where you can see that. And next, let's go into the IAM. First, let's look into the IAM. So local variable, and then data plane here to get my account ID and all, and this TLS certificate for our OIDC, random suffix so that there is no what we say name convention mismatch. For that we are using this, and then EKS cluster role and policy. So here we created that EKS cluster role, and this is the assume policy, trust policy that we are adding to our EKS cluster, and this is the policy that we are adding to that cluster. Sorry, role. And next, a node group and attaching policy to that. So this is the assume role policy for that role, and next we are adding different policies for that, like EKS worker node policy, CNI policy, container registry read only, EBS CSI driver. So all these policy we are adding to the worker nodes. And next here we are creating OIDC, a role and policies for that. So firstly we created, here we are creating a trust relationship policy, and then we created OIDC role and attached some policy to that. And this is just attaching that policy. Here we created the policy, and here we attached that policy. And next, let's be look into the EKS setup. So EKS name role ARN means the cluster role, version, VPC config. We are setting this all in a private subnet because this is a private EKS cluster. Endpoint access, again values are coming from TFR files, but private access will be true and public access will be false. And security group ID that we just created in our IAM, and access config we are using the API way. Bootstrap created admin version means the one who is creating this EKS cluster will get the admin permission, and then adding some tags also. And then EKS OIDC, creating OIDC here we are using this client ID list thumbprint list means this is required for our OIDC, and we have created that here. This one, TLS certificate, and the URL of our OIDC. And next we are adding some add-ons. Again, values are coming from our TFVAR file, and here we are creating a node group, and desired size, min size, max size, instance type, capacity type, on demand or spot instance, whichever you want. We are taking on demand, label, update config, and tags all. And one thing I forgot to mention that here it is. So I told that this auto scaling group will launch the EC2 instance in this node group. But how our cluster autoscaler will get to know that which autoscaling group to trigger, because we can have multiple autoscaling group, and that happens based on the tags that you gave. I will show you that as we gave here. Tags kubernetes.io cluster, name of the cluster is equal to owned. This tag will be added to our autoscaling group, and only that autoscaling group will be triggered. These tags are very much helpful. And then we are launching an EC2 instance also, so that we can access our EKS cluster. It's like a basically jump host from where we are accessing our EKS. It's just a simple EC2 instance. And also we are adding some user data here, like updating it here, adding AWS CLI here, AWS CLI, adding kubectl, and then also EKSCTL, and also created some security group for our EC2 instance, and that's it. The EC2 instance is created. So these are all in modules folder, and here all we are calling in main folder, main.tf, source as modules.tf, passing all the values from here. Here also we created that variables.file, and values are being passed from here. So this is like modular code, and if you want to pass any other value, you can create another file like prod.tf files and pass some other values for that. And when we are calling this file, launching this Terraform code, we can just change the attribute type, like I'll show you that while doing. So these are the values that we are providing. The subnet CIDR blocks, availability zones, private subnet CIDR block, names, the CKS create cluster and all, version, instance type, add-ons, so CNI, core DNS, kubeproxy, and CSI driver. So these are all we are doing. And now let's apply this. Come into CD EKS. Firstly, do Terraform init. So let me show you this also. So in backend.tf, we are also creating a backend. So this is the bucket that I have, and in that bucket I'm creating this EKS folder, and in that EKS folder our .tf state will be stored. Use log file as true, and region also we are providing from here only. So firstly let's initiate the Terraform init. Do this. So it will take a while. So Terraform has been successfully initiated, and next let's use Terraform plan. As I told, we are using tfvars format. So how you can pass that, hyphen hyphen var file equal to dev.tfvars. So this will plan our complete infrastructure before applying, and you can see that 35 to add. So you can look over here, everything is being added, our subnets and all those things. You can peacefully look out there, and what I'll do is finally I will apply that. Terraform, apply. So I applied that. So again it will take like 15 minutes nearly to apply your configurations. Type yes, and it is now creating everything, your VPC, your EKS cluster, and all the components of your VPC, IAM policy, rule, everything will be created. It takes nearly 10 to 15 minutes. So have patience till it gets in a working state. So till then I'll pause this video. So see, our complete infrastructure has been added now. 35 added, 0 changed and 0 destroyed. So now let's look into our infrastructure. So these are the EC2 instance that have been launched. So this is the Bastion host from where we will be accessing our EKS, and this is one of the node group that is being launched. And this is our EKS cluster, and this is our VPAC, and all the components you can find here, subnet, routable, and all. So now what I'll do is I'll show you one more thing. Come to your cluster and in compute section, this is your node group, and go inside that and see here auto scaling group no, name. One auto scaling group is associated with your node group. So let's go to that auto scaling group. So this is that auto scaling group, and here if you go to your tags, see here you can see the tag. Based on this tag only, auto scaling group is triggering your cluster autoscaler is triggering your auto scaling group, and this auto scaling group is adding new nodes in that node group, this node group. So currently we have just one node in this, and yeah, that's it. And now let's access this. What I'll do is I'll connect this, take this, and in this instance I've already added all the required things like CLI, kubectl, and all those things. So I'll directly configure this AWS and make sure to configure this instance with the same user that has the access here. Come to your access and see one of the IAM user, Terraform user, and this user only created your EKS, my complete infrastructure from this Terraform. So this terminal is configured with that Terraform user. So I will configure that same user from here in this terminal also, in this terminal. So as added AWS STS, you can verify using this command AWS STS get caller identity, and you can see that user. So now I will use this command AWS EKS update kube config region and name of your EKS. So this is my name of my EKS cluster and dev EKS demo. So you can check that from here also. See here, dev EKS demo. So I'll simply hit enter. A .kube config file will be created, and now I can easily access my cluster. kubectl get pods. Yeah, no resources. We don't have any pods running here. So let's say kubectl get ns. Yeah, it's okay. And now next, let's create a deployment. kubectl create deploy nginx app image nginx. A deployment is created. kubectl get deploy. So let's wait until it gets in the ready state. So it's in ready state. kubectl get pods. One pod is running, and which image it is using, nginx image. So what we will do is now we will increase its, now just one single pod is running in that node, so it's easily serving the traffic and its status is in running. So now let's increase the number of replicas and see kubectl edit deploy nginx app, hit enter. So we'll get this configuration. Come here, see here, in spec we have these replicas. So just change it to 10, and then create this. A deployment is edited. So kubectl get pods. See, 10 pods are in now running state. Again, these 10 pods are easily served by that one single node. And you can easily check your logs also. Kubectl get events. And here you can see that deployment nginx app scaled up replicas from 0 to 1, and then next again I unscaled from 1 to 10. And now let's scale it again. Edit deploy. Let's make it 20 and see whether it is again able to launch all those things. Again updated. Kubectl get pods. Okay. Now some are in pending state. See here, here, here. So kubectl get deploy. So okay, it's adding only 10, not more than 10. So 10 are available and 10 are not being in pending, which are in completely unschedulable state. You can also check kubectl get events. So it's scaled from 10 to 20. Okay, and now let's also check ctl get nodes. Now we have just single one node, and it's the ideal state, right? And this one single node is not able to take all those pods in just one single node. And what technically should now happen is to increase the number of nodes. For that we need to deploy our cluster autoscaler. So now we need to launch a cluster autoscaler in our Kubernetes cluster. So how the cluster autoscaler is running in this cluster, though it's not running yet, we will launch that. So it will be running like a pod inside our cluster. So we'll add that, and that cluster autoscaler will be responsible for launching for our nodes inside our cluster. Like it will be triggering our ASG and all. And again, I have told in my previous videos, like if any pod needs a permission to access some other AWS services, what we need to do? We need to create IRSA so that pod can get some permissions. Like here, that cluster autoscaler needs the permission to trigger our autoscaling group so that new nodes can be added in our node group. So firstly, we will create IAM role, IAM policy for that cluster autoscaler. So let's go to your console and create that first. Now come to your IAM, and I have already created those rules, but still I will show you how to create that once again. So come to your policy first, create a policy, and come to JSON. That will directly copy paste that policy. So you can follow that. Come to this Kubernetes cluster autoscaler. This is the official documentation provided by cluster autoscaler itself. I also mentioned that policy here also. You can take this policy here from here also. So you can see that here also. See here. This is the same policy that I would took from here only. These are the official documentations provided by Kubernetes itself. So come here. So we'll paste that policy here, and then next. So these are the things that been added: EC2 and EC2 auto scaling, and give a name to your policy here, and simply create a policy. A policy will be created. Though I will not create it once again because I have already. Let me show you that. See here, I have this policy already. Cluster auto scaling policy. This is the same policy that I have added. So once the policy is created, now let's create a rule. So come to rules. Again, I have also created a rule also. Click create rule. Come to web identities and choose this OIDC provider and this OIDC provider we already created via Terraform. So just click this and OIDC provider will be selected, and remember this name BE3. My is BE3, your could be anything else, and audience will take STS Amazon AWS, and next, and here we'll take that policy. What is that policy? Whatever the name you have given. For my, it is this. I will take this policy. Next, give any name to your role. And one thing you need to update it here also, that is audience is present but subject is not present. So for that, what you need to do is edit this. So what happened? Next, give any name here first. Uh, Cluster tools, okay. And then edit this. No, it's not allowing me to edit. So what I'll do is I'll show you that what to add. Let's cancel this. Let me go to my created, already created role. So this is the role that I have already created, and come here to trust relationship. You will get this one, and then click this edit role policy, and then you need to add one thing here, that is this STS audience has been added, but you need to add this SUB, and for that you can I have already mentioned here also. See here, you can take this, not this one. What this is saying first, let me first discuss this. So here what we are doing is we are creating a service account in the namespace cube system, and the name of that service account is this cluster autoscaler. So we are giving permissions to this cluster autoscaler on this service account only, and this service account we will create in our cluster. Now you have we take this, copy this, and come back here and paste that here. You need to update this. So what I will do is I'll update this one. And once you update this, just update the policy. A policy will be created for your role. So yes, now your roles and policy is completely created. So now what we'll do is we'll add that pod of cluster autoscaler. So for that, what you go do is go to this official documentation. The link will be provided in the descriptions. So come to here in this example section, go to this cluster autoscaler auto discovery, and in this you need to take this complete YAML file. Take this YAML file, go to your terminal, and vim cluster scalar cluster2.yml, give any name, and then paste that file. So that file is added here, and see in this file you need to update one thing, and see a service account that is being created here, and name of this service account is cluster autoscaler, and this is the same name that we gave in our role that we created here. See here. By this, what we are saying is give only permissions to this service account. So that service account we are creating it over here. And one thing we need to add is annotation. That is this annotation. Take this annotation and over here. So this annotation and this annotations role. What role you need to add? Take this role that you created just, and then paste that role over here. So this is the role, and then simply save this, and then apply that file. kubectl, and firstly let me show you that kubectl get pods. Our pods are still in pending state. Kubectl get deploy. See, only 10 pods are running and 10 pods are in pending state. So let's apply that first. Kubectl and also see get nodes. We have only one node, and now once we will apply our cluster autoscaler, new node will be launched, and these pods will, which are in pending state, will be coming in running state. Kubectl apply that cluster autoscaler. See, service account, cluster role, and then role binding deployment, all are being created. So let's look at that. Kubectl get pods in the namespace cube system, because these are being created in cube system namespace. And here you can see that cluster autoscaler is being created. It's still in creating state. Let's wait for that. And yes, our cluster autoscaler is in running state now. So now you can check the logs also. Kubectl logs pod slash, take name of this cluster autoscaler, paste that in the namespace cube system. And here you can see some logs are coming. Pod default unschedulable, it has saw that 10 1 2 3 4 5 6 11 unschedulable pods are left, and calculating unneeded nodes, something has been calculating. Let's look at once again. And kubectl get pods still in pending state. Kubectl get nodes. Let's wait for some time. I think it takes some time to launch that node. So there is one silly mistake. So this is not being scheduling our nodes, and I have found this one, cat cluster autoscaler. And here in this configuration, it has asked us to give your cluster name here, and what I have done is here we should have updated this. So let's first update that and launch the cluster autoscaler once again. So vim cluster autoscaler, come down here and update that name of your cluster, dev EKS demo, and hit enter. Kubectl get pods. Now let's see. Kubectl, I updated that, but let's apply that. Kubectl apply -f cluster autoscaler.yaml once again, and see, deployment has been configured. Kubectl get pods. So let's wait for that. Once again, kubectl get pods in the namespace cube system. So container is still creating. Let's wait for that. Still creating. Oh, I think we should have deleted this one first and then we would have created that. Okay, let it be. Let's create kubectl delete one f pod kubectl delete that pod in the namespace kube system, not phone. Yeah, it auto got deleted. Okay, now our pod is in running state. Kubectl get pods. Let's check our pods and still not. Let's check the logs. Kubectl logs pod slash name of the pod and the namespace cube system. And again, if you need to learn how to debug this, and that's how you learn also. And again, we are failing something. Scale down calculation, ignore one nodes unremovable. What is happening? Kubectl get nodes. Okay, it has scheduled. Kubectl get pods. So okay, all our pods are in running state now. Kubectl get pods. Do again once again. Yeah, all our 20 pods are in running state, and there are two nodes. One more node is launched and that status is ready. You can check that in your console also. Just refresh this once and see one more node is added of type T3 medium only, and it's still in initiating stage. It will initiate, but it's in running state, and that is also type of T3 medium only because that is only what we have mentioned. So let's now again increase the pods and see kubectl. And if I again increase the pod, it will not be able to launch one more node because why? Because means in our configurations here, code module, not here, here I have given as min here, desired capacity, min capacity, and max capacity. Max capacity is 2, so we have two nodes running. And if again the load increases, traffic increases, there will be no new node will be launched. Now what we'll do is let's scale down and see. And once you scale down, what you will find that it will take nearly 10 minutes to update your configurations. Because what the cluster autoscaler does is, once you will update your replica set, and it will wait for 10 minutes until, and for the 10 minutes it will check that your node should be underutilized for that 10 minutes, and once it is underutilized for 10 minutes, then only it will delete that node. So let's look at now that so kubectl edit nginx app kubectl edit deploy nginx app. So let's scale down it to again 4. Edit it, kubectl get pods, and see we have 4 pod runnings, and you will see that kubectl get nodes. You have 2 nodes still, because, and now you may have that doubt like you have only 4 pods running and why we have 2 nodes still. Because to scaler takes 10 minutes of time to scale down this node, so you need to wait for 10 minutes something, and then you can see that this node is been terminated by itself. So what I did is I waited for some time and then I checked the logs, and then it is saying something like this. So this node which has this IP was unneeded for 5 minutes 21 seconds. So it is checking that node. So it will nearly check 10 minutes, and then once it is satisfied with that, it will scale down that node. So let's wait for that. kubectl get nodes. Since still the states here 120, here is last, and here is also 120. This is that same node which it is tracking. So see, finally you can see that scale down count down is true, and here in this I'm seeing this has been terminated. See, now let's look for kubectl get nodes. Yeah, it successfully got terminated. But again, this is one of the drop down of this cluster to schedule, that it takes 10 minutes to scale down your nodes, and that's what the carpenter is very useful for such things. We'll look into this more in our next video. Dive deep into the carpenter. We'll look into the differences of cluster to scalar, carpenter, and everything over there. So now we have successfully performed the demo. We looked into how cluster autoscaler scales your nodes. We looked how it launches the nodes, scales down, and also looked into the behavior of your scheduler, and then how pod comes into the pending state to running state, node group, autoscaling group, everything. So now once you have performed this demo successfully, you can terminate your infrastructure now. So what we'll do is, now let's terminate our infrastructure. So now I will destroy our complete infrastructure. Destroy, Terraform destroy, and simply hit enter. So okay, cd EKS, go inside this and then try this command. So yes, now it is destroying our infrastructure. Type yes, and it will delete all your infrastructure, your role, your policy, your VPC, your best in host, everything will be destroyed. Again, it will take 10 to 15 minutes, so have patience till then. And once it is completely destroyed, you are all set. And yes guys, that's it for this video. And if you found this video helpful, make sure to like and subscribe, because that really motivates me to make more such content. And in next video we will dive deep into the carpenter. We will look hands-on part into the carpenters, and we'll also look into the differences of cluster autoscaler and carpenter. And we'll see you in the next video. Till then, bye bye.